All right, let's try a second example in Chapter 1. We have another solution. This one's called caustic soda. Caustic soda is another name for a very alkaline or basic solution made from sodium hydroxide dissolved in water. And caustic soda here is 12.0 weight percent sodium hydroxide aqueous. In other words, it is 12.0% sodium hydroxide. And what's missing here is by mass in water. So that is the percent composition of this solution. We also know a second property of the solution, and that is density. The density of this caustic soda is 1.131 grams per mil. The question is, what volume of caustic soda contains 2.25 kilograms of sodium hydroxide? This is another example, and we'll see plenty as we go through a few chapters of solutions where we're concerned with a component in the solution. Here the component of the solution is sodium hydroxide. The solvent in this case is water. All right, so given this information, we can, what you want to do is identify any conversion factors that are here, and we have two. So you want to think of percent composition as a conversion factor. You want to think of density as a conversion factor as well. So here are the two conversion factors that we have. Excuse me. Let's move this up. The percent composition we'll write as a conversion factor here is the component sodium hydroxide over the solution. So a 12 weight percent sodium hydroxide solution means that there's 12.0 grams of component sodium hydroxide in 100 grams of solution here, caustic soda. It's called a conversion factor because it allows you to convert between the top and the bottom. Here, mass of component and mass of solution. So when I'm asked, what volume of solution contains this amount of component, this obviously will be used in one of those steps. Density is also thought of as a conversion factor because it allows you to convert between mass and volume of, in this case, caustic soda. And so I know that, excuse me, I know that 1.131 grams of this solution occupies a volume of 1 mil, exactly 1 mil. Okay, so now we want to get to solving this question. So, because in this chapter we're talking about conversion pathways, let's do that first, even though I think you're ready to jump into the calculation. Let's write out our conversion pathway. So let's figure out what we're going to do step by step, and then we'll execute that. Remember, on quizzes and tests, perhaps on the exam, you'll have a question that simply asks for the conversion pathway and not necessarily all the calculations. So it's very important that we know how to do this. All right, so we have to know where we're going to start given this question. And the question's asking you what volume of caustic soda contains this mass of component sodium hydroxide. So this is actually where you want to start. You're starting with what you're given, and you want to end up with a volume of caustic soda. So we're starting with a mass of sodium hydroxide. All right, a mass of sodium hydroxide. And I want to find out what is the corresponding volume of solution that contains that. Can I do it in one step? Can I convert from a mass of sodium hydroxide to a volume of solution? If I have a conversion factor that has those two things, then the answer is yes. But I don't. I can convert from a mass of sodium hydroxide, which is right here, to a mass of solution. Then once I have the mass of solution, I can convert to a volume of solution. You see? So it will be two steps. So first I will convert the mass of sodium hydroxide to a mass of solution, and my solution is, in this particular problem, caustic soda. And then once I have that corresponding mass of caustic soda, I can convert using that conversion factor to a volume of caustic soda. Okay? To convert from the mass of sodium hydroxide to the mass of caustic soda, I'm looking for a conversion factor that contains both of these. It's right here. Okay? Mass of component, mass of solution. And so I will use the conversion factor of, what is this? Percent composition of my solution. And to convert between mass and volume of the same solution, that of course is density. That's what's used there. All right, let's proceed and plug the numbers in and actually solve this question. There we go. So we'll start 2.25 kilograms sodium hydroxide. So I have this mass in kilograms, but my percent composition conversion factor is in grams. So a quick conversion, all right? So I want to get rid of the kilograms, and I want to use grams. Great. So again, I'm being really thorough here in this practice. I think most of you would write 1,000 grams per 1 kilogram here. Okay, so now I have my units in grams of sodium hydroxide. I want to use my percent composition because I want to get rid of my grams of sodium hydroxide units, and I'm trying to convert to a mass of caustic soda, so it has to be the same unit of mass, which is grams. Oops, caustic soda. And now I can fill in my numbers. So my percent composition tells me it's 12.0 mass percent. So I know there are 12.0 grams of sodium hydroxide in 100 grams of solution caustic soda. Okay, now that I have my mass of caustic soda, because everything else has canceled, now I'm converting from grams of caustic soda to a volume of caustic soda. I'm going to use milliliters because those are the units of my conversion factor. Okay, so you see these units are going to cancel and I'll be left with those. Fill in the numbers from the density information. And the density is 1.131 grams per mil. So 1 mil has 1.131 grams. The question was actually asking what volume in liters. What volume in liters? Let's pull that back. I hadn't written it, but it's what volume in liters. Okay, so let's bring this back. So I'm going to have a volume here in milliliters. So continue this calculation, and let's put mils on the bottom so it'll cancel. Liters. There we go. 1 liter, 1,000. Okay. So a quick check of the units before I do the numbers in the calculator. Kilograms of sodium hydroxide will cancel with kilograms of sodium hydroxide. So this is effectively converting kilograms to grams. Grams of sodium hydroxide go out with grams of sodium hydroxide. That leaves me with grams of caustic soda, but that cancels right here. Leaves me with milliliters of caustic soda, which will cancel with these units. And I'm left with that which I'm asked for, liters of caustic soda. So I know that my answer is correct. So in the calculator, ready? 2.25 times 1,000 times 100 divided by 12.0 divided by 1.13 divided by 1,000. We'll get an answer. What did you get? Calculator is probably displaying 16.578 liters of solution, caustic soda. Now you want to check your precision. Look back at the question and see what number is actually limiting. The density was 1.131, so that's 4 sig figs. But the mass percent composition was 12.0, so that's 3. This whole thing is multiplication, so you'll choose the given information that has the least number of sig figs to tell you how many sig figs are in your final answer. 12.0 is 3, so I need to round this to 3 sig figs. So that'll push the 5 to a 6. My final answer should be 16.6 liters caustic soda. And again, on a test and certainly on an assignment, you need to put a box around your final answer, nice and neat. And there's our final answer, 16.6 liters.